So this first one is about as easy as they come. You are supposed to graph all the points that have a radius of 2. So take a second and think about where that is. And hopefully you came up with these points. All the points on this ring have a radius of 2. And if you connect them, of course that's a circle centered at the origin with, big surprise, radius 2. Those are easy. It gets a little harder with this one, where r depends on theta. And so the way I want you to really think about this is to make a table of points, and I want you to connect them. But here's a philosophical difference. When you graph XY graphs, we usually start at the left and graph to the right, which means x is increasing. And as x is increasing, y varies. With polar graphs, you're going to let theta increase, which means that you are going counterclockwise. And as you go counterclockwise, r varies. If r doesn't vary, you just get a circle. But when r does vary, you're going to get some other shape. So you're moving counterclockwise, but maybe your radius gets larger, your radius gets smaller, your radius gets larger, smaller, whatever. Okay? And this is calculus. We take things that used to be constant, and now we let them vary more. So we'll be looking at those. So I want you to make a table of values, and it's probably best just to start with theta and r. Start with some easy ones. Start with theta is 0, maybe pi halves, pi, 3 pi halves, 2 pi. So go ahead and fill this in. All right, hopefully this wasn't too hard. Sine of 0 is 0, so this should be 1. Sine of pi halves is 1, so this is 2. And let's just graph those two to start. So you've got theta is 0 and r is 1. That's this point here. Theta is pi halves and r is 2, which is this point here. And just to emphasize, we're going to let theta increase. So you're going to graph this region between theta equals 0 and theta equals pi halves. So you're going to start at this point here, and you're going to graph in a counterclockwise fashion. Notice that your r should be increasing. So you have a slightly larger and larger radius as you move counterclockwise. So it's not some helter-skelter thing, right? R is increasing. My next subinterval, I'm going from theta is pi over 2 to theta is pi. When theta is pi, my radius is 1 again. So now my radius will be decreasing as I graph in a counterclockwise fashion. So all my radii in this region should be between r equals 2 and r equals 1. This is easy now, but I'm making this point because it's going to get harder. All right. We continue. In our next subinterval, we end up back at the origin, which you may remember is called the pole in polar graphs. So I'm going from pi comma 1 to 3 pi over 2 comma 0. So you go into the center, into the pole, and you should graph through all the theta values between pi and 3 pi halves as you go around. And then we go back from the pole out to 2 pi comma 1. And again, technically you're moving through all those theta values. And you get this graph, which you may remember is a cardioid because it looks like a heart. We'll do another one. Okay, we're going to do 3 more graphs. So with this one, and you can pause and try this yourself if you like, r is equal to 2 cosine theta. Again, I would encourage you to start with some pretty basic values. So hopefully you can start making a chart. And when theta is 0, r is 2. When theta is pi halves, r is 0. Interesting. So you should think about, how do I connect these? Do I connect them with a straight line? Do I connect them down this way? All right, and the key is that, remember, your thetas should be between 0 and pi halves. So you're graphing in this region, and your radii should be decreasing from 2 to 0. So I'm going to do this. Okay. The next part, if theta is pi, my radius is -2. So now we have to be a little more careful. So pi comma -2 actually brings us back to this point. And one of the important things is that the radius is negative in this entire region. So instead of graphing between pi over 2 and pi, we have a negative radius. So we need to be graphing in the opposite quadrant. So instead of graphing between pi over 2 and pi, we're going to be graphing between 3 pi over 2 and 2 pi with the negative radius. I have to connect this point to this point through this region, and I do that like this. What's interesting is that if I keep going with this chart, at theta equals 3 pi over 2, I should get a radius of 0 again. So let's think about where that is. So again, I have a region where r is negative. So instead of graphing between pi and 3 pi over 2, I'm going to graph between 0 and pi over 2. So I have to connect pi comma -2, which is this point here, to 3 pi over 2 comma 0, which is this point here. Any point with a radius of 0 is at the pole. So when I connect these, I'm actually traveling over my original graph. You don't need to do that. So what you can do is you just stop here and you say, I only need to graph between theta equals 0 and theta equals pi, generates my entire graph. Now, if I had been a more careful grapher, this should come out to be a circle. So it really looks like this. And it should look like a circle with the x-axis as a diameter with a diameter of 2. But when you generate these, it's going to become very important to know what theta values you need. It's actually going to be the endpoints of your integral, so we need to pay attention to that. Why don't you try this graph? It has the same sorts of issues. All right, so when I start graphing this, when I graph between 0 and pi halves, I connect these 2 points between 0 and pi halves. When I go from pi halves to pi, I'm going to be going back into the pole. So I graph between pi halves and pi. And now when I look at the next region, again, I have negative radii. So instead of graphing between pi and 3 pi halves, I'm going to be graphing back in this quadrant. I'm going to be connecting pi comma 0 and 3 pi over 2, -2. 3 pi over 2 is pointing south, but I have a negative radius, so that's this point. So I need to connect these 2 green points through this quadrant, and that traces over the graph again. So this is exactly the same as our previous example, and it turns out that this graph is also a circle with the y-axis as a diameter, with a diameter of length 2, and it only takes 0 to pi to generate the whole circle.